Okay, this is a different type of chapter that we're getting ready to start. This chapter is all about number theory and the real number system. Some of it is going to be quite a bit of a review, and some of it might be brand new. So I just hope that you see it as a kind of a deep dive into numbers, and the things that are a review, maybe you just appreciate that you know it already, and maybe things will come up that you have to always use your calculator for because you're not really sure of the rules. So maybe we will make those rules make more sense, and we'll just see where it goes. So section 5.1 is number theory and definition of number theory, the study of numbers and their properties. And again, we have this capital N, which is the counting numbers or the natural numbers. And N is defined as the set of numbers 1, 2, 3, and so on to infinity. Okay, natural numbers can be expressed as a product of two or more natural numbers called factors. Now, it kind of seems like we went opposite here or backwards, but a factors are two or more natural numbers whose product is a natural number. We would probably take 18 and say, find all the factors. So you might do 1 and 18 and 2 and 9 and 3 and 6. These are all the natural numbers whose product give us that natural number. So factors. So the factors of 18, find all the factors. It would be 1, 2, 3, 6, 9, and 18. All of those are factors. Now we're going to get this. A is a divisor of B, or A divides B, symbolized. We really saw how important all these symbols were on that last test. A/B. If the quotient of B divided by A has a remainder of 0. We talked about this in an earlier chapter. According to our book, it divides it if it divides it evenly. So we want a remainder of 0. So, for example, if you want to say 4 divides 12, or 4 divided by 12, symbolically, we could write it like this. Because 4 goes into 12 evenly, we have a remainder of 0. So this means 4 is divided. No. Okay, scratch that. All right, another review topic is a prime number, a natural number greater than 1 that has exactly 2 factors or divisors, 1 and itself. So your prime numbers, the numbers whose only factors are 1 and themselves. not 4, because 4 could be 2 and 2. 5, not 6, because 6 could be 2 and 3. 7, not 8, 8 could be 2 and 4. Not 9, 9 could be 3 and 3. Not 10, because it's even, 2 goes into 10. 11, 13, 15, not 15, 17, and so on. And as we look at that list, you'll notice that these are all odd. In fact, the only even prime number is 2. And 1 is neither odd, prime, nor composite. All right, so that brings us to the word composite. When you see composite, you might think composed, made up of. Composite. What's it made up of? So a composite number is a natural number that is divisible by a number other than 1 and itself. 0 isn't prime or composite because both of these definitions say it's a natural number, and natural numbers begin with 1. Whole numbers are the whole type of number that includes the 0. So 0 is neither. So when you think about 4, 4 has factors of 1, 2, and 4. So we can get 1 times 4 to get 4, or we can do 2 times 2 to get 4. So 4 is composite. It is divisible by another number other than just 1 in itself. All right. So a natural number is either prime or composite. It cannot be both. So it's a member of one club or the other. Okay, the next thing we're going to talk about is divisibility. Divisibility rules just really help us to be quicker with our mental math. So you have different divisibility rules. Divisibility. It's been a long day. You all left at 12. I'm still here, and it's 4:30. So if it's divisible by 2, if it's even, is divisible by 3 if the sum of its digits is divisible by 3. So if the sum is divisible by 3. So for the 2 rule, 3,178. Is it divisible by 2? Well, as long as that last digit is 0, 2, 4, 6, or 8, then that makes it even. So yes, this is divisible by 2. And let's take that same number and see if it's divisible by 3. We have to sum the digits, so we have to add all the digits up. So that's 15, 16, 17, 18, 19. Since 3 does not go into 19 evenly, we have a remainder. 3 does not go into that number evenly. So it's kind of handy. For 4, it's divisible by 4 if the last 2 digits are divisible by 4. So you've got the year 2023, and we want to know if there's going to be a leap year this year or not. Leap years happen every 4 years, and they happen in years that are divisible by 4. So when you check these last two digits, since 4 does not go into 23 evenly, we have a remainder. That number is not divisible by 4. So actually next year is going to be a leap year, isn't it? Because this number is divisible by 4. So 4 goes into the whole thing. 4 doesn't go into 2. 4 goes into 25 times. 4 doesn't go into 2. 4 goes into 24 6 times. Just so happens leap years and presidential election years happen on years that were divisible by 4. It's divisible by 5 if the number ends in 0 or 5. That one's nice and handy. So 2,795. Is it divisible by 5? Yes, because it ends in a 5 or a 0. It's divisible by 6 if it's divisible by 2 and 3. So let's take 712. Nope. 714. Is it divisible by 2? Yes, because the last digit's even. Is it divisible by 3? Well, 7 plus 1 plus 4 is 12. And since 3 goes into 12 evenly, yes, it is divisible by 3. I think there's a rule for 7, but our book doesn't say it, and I don't know it. It's divisible by 8 if the last 3 digits are divisible by 8. So it doesn't save you a ton of time, but I guess if it was a really, really large number, and you weren't sure, well, you could check these last 3 digits only. 8 doesn't go into 4, but it goes into 45 times, and it goes into 16 twice. So since it went evenly, then yes, it is divisible by 8. 9 is handy if the sum of its digits is divisible by 9. Look at how 9 is related to 3. 3, the sum of its digits was divisible by 3. 9, which is related to 3, right? The sum of its digits is divisible by 9. Same thing happened with 8. 8 was if the last 3 were divisible by 8. And 4 was if the last 2 were divisible by 4. So there's a relationship there with 4 and 8. They have similar rules. 3 and 9 have similar rules. So 7,382. Is that divisible by 9? Well, let's add them all up. 7 and 3 and 8 and 2. 10, 11, 12, 13. Oh, 10 and 10 is 20. 9 does not go into 20 evenly. So 9 does not go into that. And last one is 10 if the last digit is 0. The nicest one, probably. So 3,287,460 divisible by 10? Yes, because it ends in a 0. Let's see. I'm going to stop here. I'm just going to ask you to look at example 1. And I want to just remind you how to do prime factorization. You did this in geometry a lot when we did perfect squares. It's using factor trees. To break a number down to prime factors. We liked this in geometry. So let's say we're doing 18. You can break it down with any two numbers you want to. We'll do 2 times 9. 2's prime. And then we'll break 9 down to 3 times 3. And that's prime. So the prime factorization is 2 times 3 times 3, or 2 times 3 to the second power. If you need another example, you can look at example 2. Okay, good luck.